This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus, episode 683. This week, we welcome Dr. Brendon Burley, Jennifer Isenbeck, and Meghan McNulty for a show we're calling ASHRAE 62.1 Ventilation and Acceptable Indoor Air Quality. Is acceptable acceptable? Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And don't forget, after the show, we continue the discussion at afterthoughts.iaqradio.com, sponsored by First On Site. Our marquee sponsor is First On Site at firstonsite.com. Our association sponsors are the American Conference of Governmental Industrial Hygienists, ACGIH.org, the American Industrial Hygiene Association, AIHA.org, the Cleaning Industry Research Institute, CIRI Science.org, the Institute for Inspection, Cleaning, and Restoration Certification, IICRC.org. Industry sponsors are AEML Laboratories, AEMLINC.com, Particles Plus, ParticlesPlus.com, TSI Inc., TSI.com, Sunbelt Rentals, SunbeltRentals.com, April Air, April, AIRE.com, Healthy Indoors Magazine, HealthyIndoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. I'm sorry to report there was no correct answer to last week's IAQ Radio Trivia question, which was, including shared numbers, how many international climate zone names and numbers are there? The answer was 17. The IAQ Radio Trivia question for today, December 9, 2022, has been sponsored by TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations at tsi.com. Here's today's IAQ Radio Trivia question. In what year was the first patent application filed in the U.S. for the technology used in continuous operating refrigerator, which can be made without any moving parts? Back to you, Joe.
Interesting, Cliff. All right, we've got Dr. Brendon Burley. He's been in the design industry since 1998, providing freelance CAD services for a number of clients in the Philadelphia area before he moved on to work on his degrees and research at the Pennsylvania State University. For most of the past 14 years, he's been focused on designing healthcare and higher education projects, mostly in the Mid-Atlantic region, and he is currently serving as the chair for Standard 62.1.
Meghan K. McNulty PE is a senior project engineer at Servidyne in Atlanta, Georgia. She specializes in investigation and modeling energy use, assessing ventilation systems, and compliance with local energy policies. Master of Engineering from Virginia Tech and a Bachelor's of Science in Mechanical Engineering from Princeton. Meghan volunteers with ASHRAE on several committees, including 62.1.
And Jennifer Isenbeck, PE, lead AP, is a staff engineer with Moffitt Cancer Center. In planning, design, and construction departments, she works with various consultants on implementing best practices in healthcare design, campus infrastructure, as well as providing design reviews, commissioning oversight, and project implementation into operations. She is the past chair of ASHRAE Standard 62.1. Welcome all. It's great to have you. We made it through. And Jennifer, by the way, is in Southwest Florida, and we just did a show from Southwest Florida last week, and we really appreciate all of you joining us. Well, is acceptable acceptable? We put that for the title of the show, and I guess the reason why is, well, John, let's jump right to it. Throw a clip up there.
The case for airborne transmission is airtight. This means that buildings should be the first line of defense. This wouldn't be a problem, except for the fact that we haven't designed and operated our buildings with health or respiratory infection control as the goal. Instead, we've had standards that target bare minimum ventilation rates, like the ASHRAE Standard, ventilation for acceptable indoor air quality. Acceptable is not acceptable. These standards have led us to seal up our buildings, choke off the air supply, despite decades of science showing us that current ventilation rates are too low. So we have a novel respiratory virus that spreads nearly entirely indoors, smash up against our buildings that have low ventilation rates by design. Is it any wonder why this pandemic has been so devastating?
Well, let's start with you, Dr. Burley. Are our buildings by design having too little ventilation?
Well, I think you need to understand that ASHRAE Standard 62.1 defines what is acceptable in indoor air quality, and that is an environment that is not objectionable to 80% of the building's occupants. So in terms of the ventilation rates that are defined in the standard, these have been increased over the years. We all remember sick building syndrome from the early 90s. In response to that, our standard increased ventilation rates to levels that were closer to historical norms, which were traditionally around 20 CFM per person. But we divided it into two parts, a person part, which goes back even further in history to around 4 to 6 CFM per person, typically 5 to 15 is the kind of outset that we get, as well as a floor area rate, which is 0.06 CFM per square foot to 0.18 CFM per square foot. And that combined effect allows us to adjust our ventilation in buildings based on whether or not there are people present in rooms while still maintaining a level that is deemed not objectionable by 80% of the building occupants. So when you understand what acceptable is, yes, our rates are sufficient. Now, if you're going to add in there the idea that we need to also control pathogen mitigation, then you have an argument that our rates are not appropriate. But there's a separate standard for healthcare facilities called Standard 170 that does have higher rates and does stake some claim to controlling the spread of infections. And there's a lot more to be said about that, but I don't want to monopolize the show for just this one topic.
Well, Jennifer, you're in healthcare down at the Moffitt Cancer Center there. Maybe you'd like to comment on this.
So we went around quite a bit, particularly because when COVID hit, I was chair, and did we need to address this immediately in our standard? I think many of us that were practicing engineers were called on by clients. I guess I should preface this with, this was back when I was at a university. But when I went back and redid the calculations and pulled the original 62 VRP calcs off of drawings and buildings and looked at our airflow stations, the majority of the buildings were already achieving 2 air changes per hour. So we were already meeting the recommendations from the ETF. So they were actually 2 to 3 in most of our academic facilities. So that's one reason why I have a little frustration with those comments earlier. But in the healthcare world, we often have to mix the two standards because, again, we have everything that we base on 170, but there's many other business occupancies within the healthcare. So we really look at both. And then we also look at filtration, and nothing says we have to use the minimum. I think a good owner and operator will evaluate all of those and rely on their consultants. So as a baseline in a healthcare, we follow 170, but we also have found that 62.1 in some cases might even increase the ventilation than what the healthcare standard had offered. And we are actually going through some projects where we are weighing both options because it's a dual occupancy. So really a good engineer and a good owner and a good contractor, and you look at these buildings and systems together, and you really will see you're not choking off the ventilation supply, whether it's a business occupancy or a healthcare. I think we really need to be a little bit more practical in how we do our designs, and we commission our buildings and we operate them correctly. And that was really the other caveat, is operations. You know, we really need to look at the overall lifespan of the building.
Well, I think that's what hit me. When I saw the statements made that, you know, we don't have enough ventilation in buildings in general, my thought was that's not unusual, but I don't know that they were designed that way. They may be operated that way, as you said, Jennifer. And Meghan, you do a lot of this type of work. You look at indoor air quality. I wonder if you could comment. Do most of the buildings that you look at, are they meeting the design standards for 62.1?
Sadly, no. It's a little rough, and part of that is that stuff breaks over time. This is just one other thing that's on the maintenance list, and it's not. I think ventilation for a long time has been, oh, that's a nice to have, but today it's too cold, or today it's too hot, and but the pandemic really should change our mindset that this is a non-negotiable. We have to do this all the time, and it's just not. Buildings aren't doing that. We took a subset of buildings we assessed in response to the pandemic, and off the bat, only a little less than half were meeting 62.1. A little less than half. A lot of those could get there without like massive changes. Just fix a few things, change some controls. But if we're not taking those small extra steps, then we're not going to meet this floor, this absolute worst that you're supposed to provide. We're not doing that broadly, and we need to.
Yeah, that seems like a big part of the issue to me, is that, we're not even meeting that level of standard of care. And I guess, Jennifer, with you being in Southwest Florida, you also have to, you talked about balancing things. You also have to balance bringing in more ventilation air with conditioning that air, preconditioning, I guess you could say, because it's oftentimes hot and humid air, which causes its own problems. I wonder if you could comment on that.
Yes. So I'm going to say, fortunately, most of the systems I get to work on are chill water systems. For those that know, there's so much more forgiving when it comes to dehumidification. You're not worrying about refrigerant. You're not worrying so much about refrigerant leaks. You're not worrying about hot gas bypass and reheat and multi-stage compressors. And it's gotten so complex that a lot of the DX systems, while they can handle this hot, humid air, they tend to have more problems. And of course, the Florida weather and sun just beat up that equipment quite a bit. So, kind of our rule of thumb, in a lot of these systems, particularly air-cooled chillers, rooftop units, their lifespan is only 10 to 15 years. But in particular, one of the examples, one of the buildings that we are replacing all of the chill water air handling units, it's a 5-story lab building with a vivarium, and we're replacing 14 30,000 CFM, 100% outside air handlers for this particular research laboratory. And it's such an energy hog. But again, we have to look at ways of energy recovery. So we did multiple models, and what we looked at was, for the ease of operation, we are actually using chill water with a glycol runaround loop. So we're pre-cooling the outside air, then cooling it down to 48 degrees, and then using a little bit of that reheat, because the problem is again, then you're using all the more energy to go reheat down in the spaces at the air valves and adding another extra energy intensity to it. So whatever we can do to do some sort of energy recovery, but you really have to get that air down to that dew point down here in Florida. I mean, bringing something down to 58, 60 degrees is not going to dehumidify in August and July. And we're really I looked at the ASHRAE tables, and it is getting definitely more humid and more warm down here. And we really have to look at those dehumidification points.
So you're balancing not two things, three things. The extra ventilation may cause issues like humidity and mold and things of that nature, but also it costs more money to deal with that extra ventilation. So I can see, Dr. Burley, it sounds like you're oftentimes caught between a rock and a hard place on this committee. And it looks like ASHRAE's kind of recently just announced, I think yesterday, they've committed to developing an IAQ pathogen mitigation standard. Can you tell us a little more about that?
So there's not a lot of information available yet. I can say that ASHRAE staff and the board of directors has been in contact with myself, as well as the chair of 62.2, which is the companion standard for residential ventilation, to discuss what the composition of the authoring task group or committee will be for this standard. It's important to understand that this will not be an ANSI standard nor a consensus document. It is something that is being developed for the White House, for the US government, so that they can provide an indoor air quality standard that can at least help to address pathogen mitigation. Right now, it is so new that we don't have a leader yet for this task. We're hoping that we get that information within the week because we only have 6 months to develop it. And we're working very closely with members on the committee, as well as members. Well, Bill Bonfleth has just said that he is officially the chair. So
we're breaking news here on IAQ Radio once again.
There you go. So I'm sure that we'll be in touch with Bill shortly to get membership out there. But I do understand that 170 has expressed interest. That's the healthcare ventilation standard, as well as several members of our own committee and members of 62.2. And there are probably many others in the broader ASHRAE community that will want to serve and help in developing this standard.
So this will not necessarily be a consensus standard. Is that accurate? I mean, maybe you could talk, or one of you, anybody wants to jump in on why does developing a consensus standard kind of make it, first, it makes it more, I think, acceptable for a lot of different groups, but on the other hand, it probably does the opposite for some groups. They don't like that it's a consensus standard. Can you, one of you, talk to us about the kind of push and pull of developing a consensus standard?
So we were talking about this yesterday, and I likened a consensus standard to a regulation, or tried to emphasize differences, saying, let's look at the coal industry. If a regulator in the federal government were to sit down with coal miners and develop a standard, people would say you're in the pocket of big labor. If they were to sit down with the developing companies, the developers, they would say, oh, you're in the pocket of the coal industry. If they were to sit down with the environmentalists, they would say, oh, you're in the pocket of big green. If you develop a consensus standard, you want all of those players at the table with you. And you want them to agree that this is what we should be doing together as an industry. And that means that everyone's going to have to give something up. They're going to have to say, well, I really would like it to be this way, but there's a limitation either in the cost of it or the technology of it. And that's what a consensus standard is. And that's why a consensus standard takes a long time. And that's why people complain that you get bogged down in politics. And yes, all of those are true. Politics can come into play, but it doesn't mean that the whole process is arrested just because there's one naysayer. In fact, you can pass consensus standards forward with objectors. It is not ideal, but there is a process for it. And we have had to do that in certain circumstances where the preponderance of the evidence, as well as the majority of the committee, has wanted to move forward with changes that were deemed appropriate, despite the fact that there were vehement objections by certain members. So we shouldn't look at a consensus standard as being a unanimous standard. It is not, but it is a process that brings all shareholders to the table and tries to develop an agreed set of rules that we can all live with. And that's what makes it beneficial and different from, say, a regulatory standard, which may not have all those people at the table, and oftentimes can still be influenced by politics, but is more prone to proclamation by fiat, which leads to things that are technically unachievable and thus ignored or not regulated properly.
Why don't we go? I know you sent me some slides to kind of help people understand a little bit about 62.1, the standard and the revision that's going on all the time. And I know there's been 2 revisions here in the last, 6 years, I guess it would be. And we haven't done a show on 62.1 in quite a while. So maybe we could go through those slides and get people caught up onto exactly what revisions have occurred and why. So John, if you could put that first one up, and I don't know who wants to take the lead here, Meghan or Jennifer or Brendon, whoever wants to take the lead, jump in and give us a little outline on exactly what the committee is and what they do.
Okay, I'll start off with that. And generally, our committee is broken down as you see here. In fact, we actually have 2 vice chairs. Typically, actually this year we might only have 1, but there's the chair. You have a vice chair or more, and usually that's another person either that may be a chair or is another expert in the field that shows that balance of the committee. Currently, the subcommittees are broken down into administration, ventilation, research, education, IAQ guideline, and the coordination and outreach. Briefly going through, the IAQ guideline is really specific to our guideline 42. There was a little confusion, but when I first became a subcommittee chair, that was my first committee, which was the IAQ guideline. And we'll talk maybe a little bit about it later, but that we're hoping to get that published in the next year. It's gone out for several reviews. The other component is the research and education. Essentially, they're focused on monitoring and managing research projects, taking relevant research projects to our standard and creating addendum or responding to continuous maintenance requests based on that research. There's some addendum out right now that have been based on research projects, and they also are responsible for the putting together presentations and seminars. Ventilation systems, and it's really ventilation and equipment systems. And that's the combination of essentially kind of the building systems and equipment, and how do we get that ventilation into the building. It used to be two separate subcommittees, but we realized in order for these systems to work together, they really should be on the same subcommittee. And I look at the administration subcommittee, more of the, well, as the term says, administration, but they handle some of the continuous maintenance proposals, interpretation requests, and really the context of what has already been written into 62.1. And, you know, sometimes there might be revisions to text or language based on another code or another standard. And they work on a lot of the projects to collaborate with some of those components. And from the way I like to look at it is I like to see all the subcommittees work together and collaborate. So first, we're not duplicating work or efforts. We're showing a unified document that we don't, you know, we are working in a consensus, but sometimes one group might be going in one direction and another research and ed is working in another. And so we try to really focus on the collaboration, and then all of it actually got fed into the IAQ guideline as new technologies and research has come out.
You know, I think you probably perked the ears of a few of our listeners when you talked about an IAQ guideline. That's, you know, we're IAQ radio. And this is an enhanced IAQ guide, 42P. Is this new or is this a revision to an existing document?
I will give the intro and I'll let Meghan take over. It is a new guideline. It's guideline 42P. P is for proposed. And it is a guideline that will be owned by 62.1. Back in 2009, there was an IAQ guide, which is a different document, but I'll let Meghan kind of talk about the story and where we're at with it.
Okay, Meghan?
Sure. Yeah, I'm going to have to jump a little bit in the history because I know that there's this guide that was really collaborative, EPA, BOMA, USGBC, ASHRAE, big, thick document. Maybe you have it.
It's up here somewhere.
700 pages, and it is.
Oh, that's the residential one. Okay.
Okay. Well,
was it residential or commercial?
This is the commercial one. It's free.
Commercial.
It's online. It's a great resource. But what we were trying to do with this indoor air quality guideline is to have something that's parallel to the minimum standard. And it provides a menu of options for how to go beyond the minimum standard, right? Like we're setting the floor in one document, and then this other document says, well, do you want to do better in this area? Here are some things that are available. Here's new research. Here are other things to consider that aren't required, but will help you out. So that's when I joined the committee in 2018, I was put on that subcommittee, and it's still in progress. We're very close. It too is going through this consensus process. It goes out for public review. We get comments from the public, which are great. People raise a point, hey, you forgot this, or consider that. But it does make it take a little longer to get published. So it is very close. We're hoping by spring to have this new document out that will be that next step up. This is the better than acceptable version.
And I would also say, because this is a guideline, we had a little bit more latitude. So in fact, we talk about green cleaning processes. We go more into operations and more in detail about commissioning, some of the things that aren't just strictly about ventilation. We talk a lot about indoor and outdoor air quality and treatment of that. So this kind of augments maybe some of the user manual, because again, the user manual, which the last one was published in 2019 for 62.1, gives you the methodology on how to calculate ventilation, but it doesn't necessarily always give you the reasoning for, or maybe a recommended practice that could be better.
One thing I'd like to add here is that this is going to be a continuous maintenance document, which means that unlike the IAQ guide that gets published, it's a fixed point in time, we will continue to update this, hopefully on a similar cycle to the actual standard. And once it's initially published, you will see a new version every 3 to 4 years that says, and here's the latest information about what you can do to really enhance your indoor air quality, because there's a lot of movement in this area. I mean, look at the number of technologies that have come out during COVID that are claiming to do certain things. And we're starting to challenge those companies, well, prove it. And we're developing test methodologies. And we have some of these companies responding. They've built large research facilities where they're trying to show that they actually do the things that they claim with their products. So in 4 years' time, we'll have a new edition of the guide, and it will have these test procedures, and it will talk about the latest technologies that are available, the ones that work, the ones that didn't. And that's so important as we're trying to make sure that we're always improving and making things better, that we're constantly reevaluating and modifying.
And to Brendon's point there, I think the general public can really help us with this constant improvement. Anyone can submit a proposal to change or update the standard, actually any ASHRAE standard or guideline. It is osr.ashrae.org. Online standard, I don't know. I'm not sure what that acronym is for. But if you come across something in your work where you think, oh, this could be done better, this could be done safer, it's more efficient this way, or if you're a researcher and your findings have implications for building codes, well, let us know. Send us a change proposal, because it just gets better with the more information we have.
You know, I want to ask, what I'm going to do, I'll set this up and then we'll come back after halftime and we'll get your answers. But one of the big complaints, concerns I hear about ASHRAE 62.1, that it's not a health-based standard. And so I want to kind of set it up for you. And then after halftime, I want each of you, if you would, to comment on it, because I think that's really a big topic and a big concern for a lot of people. And I think maybe there's a little misunderstanding around that whole, the whole idea of how you develop this health-based standard, or could it be a health-based standard? We're going to stop and thank our sponsors right now. We'll be back with Meghan McNulty, Jennifer Isenbeck, and we got Brendon Burley also, Dr. Brendon Burley. So we'll be back after this quick message from our sponsors. Our marquee sponsor is First On Site, your trusted full-service disaster recovery and property restoration company at firstonsite.com. Association sponsors are ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science. ACGIH.org. AIHA, Healthy Workplaces, A Healthier World. AIHA.org. The Cleaning Industry Research Institute. See more deeply through science and research. CIRI science.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. Industry sponsors are AEML Laboratories, free shipping, great pricing, same-day results with no rush fee, AEMLinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us. ParticlesPlus.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations. TSI.com. Sunbelt Rentals, availability, reliability, and ease for all your IAQ and restoration needs. at sunbeltrentals.com. April Air, healthy home, April, AIRE.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, we're back. I hear this kind of complaint quite a bit that the standard is not health-based. Are any ASHRAE standards health-based, and why or why not?
Well, there's actually a rule of the board, Rule 1.201.004.9, that limits what the standards can regulate around. The first provision of this is that the standard shall specify concentration limits of only those specific contaminants for which a nationally or internationally recognized authority has established a maximum permissible concentration limit and for which standardized test procedures have been established. There's some other provisions, and then there's Part D, which I think is the most relevant to discussion. The standard shall not make any claims or guarantees that compliance will provide health, comfort, or occupant acceptability, but shall strive for those objectives consistent with ASHRAE policy. So what's important here is that ASHRAE is taking a position of humility. We recognize that we cannot alone guarantee the health of the occupants. And therefore, we're not going to create a standard that claims to be for healthy buildings. If you take all of our standards together, we intend for you to get a healthier environment. So 62.1 is going to provide you with adequate ventilation. 55 is going to provide you with thermal comfort parameters. 90.1 is going to make sure you're energy efficient, which improves the outdoor environment. So it's not that we're not working towards health, it's that we're not specifically going there. And part of the reason is, what is the acceptable and quantifiable contaminant that we can regulate against or write a standard around that's going to positively affect health? Pathogen is not a contaminant, it's a collection of contaminants. It includes microbes, it includes funguses, it includes viruses, bacteria. And there are different limits for different people. Our immune systems are wonderful things. For some of us, they work very well. For others of us, they don't work at all. So what is the standard for infection? If I'm immune compromised, even one pathogen could be really bad for me. If I have a healthy immune system, maybe it's 10. If I have a super immune system, maybe it's 100. The point is that we cannot put a quantified number on it. We cannot measure it because there's an unlimited number of pathogens out there. Biodiversity alone suggests that there's going to be millions, if not billions, of individual pathogens. So our rules dictate that we're not going to even attempt to regulate it, but we will promulgate standards and guidelines that seek overall health as consistent with ASHRAE policy. I hope that answers the question, but it's important to say that we're not leaving health behind. It's just not something that's going to be the primary purpose of our standards.
So health is taken into consideration, but it's not the primary purpose. And Megan or Jennifer, would you like to add anything?
Yeah, I wanted to say ASHRAE needs to stay its lane. We are an HVAC&R organization. And also, I should also, again, preface, the three of us, we are not speaking for ASHRAE. We are only speaking our personal opinions. We happen to be members of ASHRAE. Only the organization can speak for itself. But we love our organization, so we're all volunteers. But anyway, back to, ASHRAE does have to stay its lane. And while we have members of various backgrounds, industrial hygienists, scientists, physicians, the majority of us are engineers, and we know what we can do. For us to step into health and other related fields that are not in our level of expertise, that would be an overreach. Instead, we would rather work in collaboration with other organizations. And as Brendon said, our goal is to achieve a healthy and indoor environment, but we cannot be the specific one to write those standards.
Okay. Megan, did you want to add anything?
Yeah, I think a concrete example is we can't come up with, well, here is the limit for formaldehyde that is best for you. But if someone else says, hey, formaldehyde should not be above this concentration, great. that is what we can use. We have a target, we can design for that. But if something is like, this thing is bad and it ranges in orders of magnitude, well, then it gets kind of hard. And we can't decide based on these rules that Brendon talked about, like we can't say, well, here, right now. So it's maybe it's more of like a nuance than like, we are not opposed to the building enhancing your health. But as everyone pointed out, there's a lot that goes into that, right?
Well, there is. Go ahead, Brent.
I'd like to just take a moment here to talk a little bit about Standard 170 and the way it treats the subject, because 170 is unique in that it's ventilation for healthcare spaces. And they do have a lot more information in that standard about infection risks. And they have developed requirements for the systems within that standard to control known risks. So for example, within operating rooms, they have specific requirements for the types of the diffusers, the face velocity off of those diffusers, where they need to be placed relative to the patient on the operating table. In airborne infection isolation rooms, there are specific rules about how the exhaust systems have to be designed, where you can place your inlets within the room, where the supply should be in the room, what pressurization has to be maintained next to adjacent spaces. Pressurization is also core to any environments that need to be kept sterile, like sterile supply or central sterile processing divisions. So where we know and understand the risks, we will write a standard to control those risks. And I think that's important for people to understand, is that standard doesn't claim to guarantee health. It doesn't claim to eliminate SSIs, but they do consider themselves to be looking at asepsis, as they call it, or the lack of spread of disease within those spaces when they consider those standards.
Let's do this. The standard changes every 3 years. And like I said earlier, we haven't done a show on 62.1 in a while. Let's go back to the slides and maybe you could walk us through what's been happening here with the standard over the last 6 years or so. And I'd also like to focus at some point on the IAQ procedure, because I think that kind of also helps to tie some of these topics together. So Jennifer, you want to jump back in here and talk a little bit more about the standard?
Yes. So as we spoke about the standards, so the ASHRAE standards are really for method of testing and designing and installing equipment. And that's really where our focus will be. We also have some safety standards such as 15 and 34 and 188, which the 1534 is refrigerants and 188 is water treatment and Legionellas. So we do look at safety in our standards as well. And that committee is compromised a little bit differently. We really want to make sure we don't have over influence. This was just a general slide about the overall organization, and we have 3 primary councils, and all of these work together. The standards particularly comes out of the Technology Council.
And the standing committee, ASHRAE 62.1, that's a standing committee. Okay, let's go to the next slide, John.
Oh, so this is when ASHRAE first started, was actually really a SHEEV, which was for heating and ventilating engineers. And there was a recommendation of 30 CFM per person. But in 1973 is when 62 was just first published, and it was just 62, and it was just ventilation and indoor air quality, or for indoor air quality. We just recently changed it. Throughout the years, there's been changes, and as Brendon said, we went down because of the energy crisis. Then we had some outbreaks, some poor air quality problems, and then we raised it back up. And then in 2004 is when we really moved to multiple methods and procedures to introduce ventilation. So VRP, for many of you that already know, that's the ventilation rate procedure. And then we added the indoor air quality procedure, which is more of you are able to decrease your amount of ventilation if you're able to clean your air, so to speak. And that's another response to energy demands. But we also are finding that obviously with this past 2 years, the IAQP is also could be relevant for a lot of other sources. And then we
Yeah.
also have the natural ventilation procedure, which can't be used in every environment, but that was actually something that for mild to neutral climates, natural ventilation makes a whole lot of sense.
Okay, next slide, John. That was 2004. I didn't know that 2004 was when that. Go back 1 second, John, if you would. The IAQ procedure was added in
It was
2004.
actually probably before then. I want to say 96, 90.
Okay, so it's been around for quite a
Yeah,
while,
sorry.
but it has been revised.
Yes, we
Okay.
just published an addendum that now has revised it.
Okay, next, John.
And here is just an example of how it has changed periodically throughout the years.
All right, next.
And here is just an example of specific ventilation standards. So as Meghan said, we had 62, which is 0.2, which is ventilation for indoor air quality in residential buildings. We have ours, and then the healthcare facilities, which Brendon touched upon. And then it's interesting because again, there's a lot more relevance in 62.2 nowadays. Again, I have to cite that we have these high-rise residential buildings, and frankly, they weren't ventilating them properly, and they weren't exhausting, and there was a lot of problems with, kitchens and smoke development and all that. So that one could be a discussion for another day, but that is definitely something that worldwide we really need to focus on.
I'm glad you pointed that out, because I think a lot of people, when they think about 62.2, they think about single family residential properties, and it's much more inclusive, much more broad. It's a much broader standard because we have, like you say, and in some countries we got 80-story residential properties. That's quite quite complex. Let's go to the next one, John.
Yep, and here is where 62 or some version of it has been, let's just say a portion of it has been implemented. So in many cases, section 6, which is the procedure section for 62.1, is really the only component that's been adapted by code, but there are various other sections, and section 5, systems and equipment is actually a very important section too, but this just kind of gives you an example. In the US, again, 62 or some version has either been accepted or adapted into the code. And that was another thing is 62.1 is an ANSI document as well. So basically we follow their consensus process. And then we also work with other model code agencies. So we are compliant across the board.
Two things jump out at me here, and maybe you could correct me if I'm wrong. Montana and Wyoming appear to be kind of on the cutting edge, and California, I'm not sure if they're a 2009 or a no statewide adoption. Does anybody know?
They are
Yeah.
Title 24.
They do their own thing there, but and not to say it's bad, like it's good. They're things out west tend to happen a little different.
They're in a little different world in California there. Okay. But I was just surprised to see Montana and Wyoming it appears they've adopted the most recent versions.
Yeah, some states, every time there's a new one or every 6 years, they automatically update. In Georgia, it's a suggestion that every 6 years it gets updated. So it's kind of becomes a patchwork across the US. And as Jennifer mentioned, these model building codes are usually only taking or offering the option of using a small bit of the ASHRAE standard for acceptable indoor air quality. So a chunk of acceptability, not the whole thing.
John, let's go to the next slide. All right, here's what we want. What's new with ASHRAE 62? Who wants to jump in here?
I'll
Meghan?
lead off, I was say, and then hand it off to them because I had my so.
Go ahead.
So one of the big things, and this happened in the 2019 version, we cleaned up, and it's now called Table 6-1, and that is the table that these ventilation rates come from. So most engineers typically still use the ventilation rate procedure. This is the procedure that is typically adopted into the model codes. So the previous table, and it might be on one of the slides, it had all these notes at the bottom of it. And you were trying to read, okay, what does G mean? What does this mean? It cleaned up the table, and it just made it a much simpler document to follow. And I'm sure for some of the code agencies, it made that easier for them too, or will once they adopt it. The other thing that I wanted to point out is we got rid of 2 appendixes that really were well beyond their useful time. Appendix C and D. I'm going to talk about D real briefly. So Appendix D was called Rationale for Minimum Physiological Requirements for Respiration Air Based on CO2 Concentration. So this became kind of the informative appendix on assisting with the demand control ventilation requirements and, you know, that Delta 1000 ppm CO2. That is gone. You know, ASHRAE now has a position document on carbon dioxide. I think we've had a rough couple of years with does carbon dioxide, is it a contaminant? Does it, you know, belong as a measure in our standard? But really it's a measure of indoor bioeffluence and what's going on in the space, but it's not really, you know, again, there's what is your limit on it and what kind of study. So in essence, we got rid of that appendix. It's outdated, and we are working on that, and I know Brendon's having fun with that on updating the demand control and CO2 concentrations. The other appendix that is out of date that we removed was a summary of selected air quality guidelines. Well, this was this, you know, informative appendix of pages and pages of different air quality guidelines and this and that. And again, I think this kind of is an example where ASHRAE stepped out of our realm and started getting involved with EPA and other, you know, OSHA and other quality standards that really, you know, what we need to reference them, not, or basically have the engineer or the owner reference the appropriate reference, not us giving them this list. It really did make things complicated. People didn't know what contaminants they were looking for. So it was a good move to get rid of that. So those are my 3 items that I was really excited that we've really modernized and moved forward with 62.
Okay. Anybody else want to jump in here with any? Meghan?
Yeah, I wanted to talk about the ways in which this is easier to apply to existing buildings and how to check for compliance. So there is a new simplified procedure for calculating the minimum ventilation rate so that you can kind of very quickly get a number, get a target. It's going to be conservative, but that gives you something to work with. There's also a table of values that can be used for the common schools, offices. Here's a CFM per square foot value that if you want to do a ballpark check, it's not for designing, but you know, do these numbers make sense? Are we around where we should be? And then there's also a whole compliance appendix that has a bunch of questions, but for existing buildings, it says, if you want to say that this existing building, built whenever, complies with the provisions in this latest standard, you have to have filters per the requirements in here. You have to calculate how much outdoor air there's supposed to be. You have to measure it. And then you have to make sure that the controls are providing it whenever there are people there. So it's not just a single number, there's a couple of steps. So that should provide clarity for what is my existing building doing? And I'm hopeful that will help us get all those buildings that aren't meeting the floor, at least to meet the floor.
What is the filtration recommendation now?
Well, currently, so it is meant to protect equipment. So if you have a coil that is going to be wet, it is MERV 8.
Okay.
And if you're in an area where the EPA says this is a non-attainment area for PM 2.5, then you need to clean that outdoor air before it comes in. But filtration is stuck in weird ways into the standard, but it's there.
Yeah, it's always been a little confusing, but you know, but that's a minimum. Okay. And Brendon, did you want to make any comments on this?
So the changes that I'd like to talk about over the past 6 years are the ones that are actually still in flux. And 170 is an example of something that we had to add because of just the timing of these updates. We brought spaces from Standard 170 outpatient into our standard for the 2019 edition because of the publication of the 2018 FGI guidelines, which removed reference to Standard 170 for outpatient spaces.
Okay, what's
One
FGI, real quick, Brendon?
Oh,
I'm sorry.
the Facilities Guideline Institute. They are a body similar to ASHRAE that focuses specifically on healthcare occupancies and promulgates design standards for those types of occupancies.
I see.
So what was really fascinating is that once ASHRAE 170 adjusted their tables to respond to the comments from FGI, we then removed them from our standard and put them into an informative appendix so that they're there for people that are in that sort of gap that we just showed with the chart with all the adoption of IMC, and they still let FGI and Standard 170 move forward with their scope of work. Another example of this that's ongoing right now is humidity controls. We changed our humidity requirements from relative humidity to dew point. And we got a lot of feedback after this was changed saying, well, wait a second, this is very complicated from a controls perspective and no one's really enforcing it. So we're working on rewriting that now so that it is enforceable, so that it achieves the goals that the research is showing us are necessary in terms of humidity control, but also respects the manufacturers and the designers' position that, hey, I can't really do this without creating a very complicated control system.
Without the existing systems aren't going to do it very well for me. Okay.
Exactly. They can, but it's a lot more complicated than the way the industry is right now. So it's going to be a great expense. So we need to get our standard to say, here's what you need to do, and give them the latitude to do it at lower expense and provide that guidance. And the last one that I want to mention is related to the notes in the table. When we remove the notes from the table, there's one note that talks about density correction and whether or not it was mandatory. Historically, the standard has not required density correction. And when that note got moved, because the language was non-mandatory, it was struck as an editorial change. And for a very brief period of time, the standard required density corrections. We said, oh, wait, that was unintentional. So we changed it back to not requiring density correction, but it got a lot of people thinking. And we are currently debating the merits of introducing density corrections into the standard and providing more guidance to the designers for how they do this appropriately. So when I think about what's new in ASHRAE 62, I'm also thinking about what's next in ASHRAE 62, because we are constantly changing and evolving. Even things that we've done in the last 6 years are still open for debate. Things that we did 20 years ago are open for debate. If someone has a better procedure than people in square footage, then they need to bring us the evidence. And in fact, ASHRAE is working on research to that front right now. We're looking at whether or not there can be factors for other contaminants that aren't necessarily tied to a person or an occupant, say maybe a pathogen load factor that could help improve our ventilation standards. But that requires research, it requires time, but building that consensus and making sure we get the facts right is so important to this process. Because if we don't do that, if we don't get that broad buy-in, if we don't have the evidence, we lose our credibility as an organization, and we lose our ability to get everyone to come along with us for what should be the standard for the industry.
That's well said. I think that's important, that a lot of people don't recognize that when they criticize what you're doing, they don't always take that into consideration. Let's go to the roundup here, John. The Roundup is brought to you by April Air, providing healthy humidity, ventilation, and air purity solutions for new and existing homes. April Air, healthy home at aprilaire.com. All right, we might run a couple minutes over if that's okay. If anybody has a hard stop, just let me know, and we'll just continue with the others. But I guess first, Cliff, do you have any follow-ups or comments, or did you see any of the questions in the chat? Because I have not been able to follow.
Yeah, no, I was following the chat, Joe, and there was some discussion questioning whether or not ASHRAE provides any guidance regarding asthma. That was one of the questions. Another is in Florida, they're still having issues, particularly in schools. A lot of parents are taking the kids out of schools because the indoor air quality is poor. There's not enough ventilation. Allergens, and so on and so forth are building up inside schools. So if we could talk really about allergens and whether or not there's any ASHRAE guidance on that, and then specifically some guidance maybe for people that are down in Florida.
Who wants to jump on that one? Dr. Brendon Burley, go for it.
Oh, I'm thinking I want to defer to Miss Isenbeck here, since she actually lives in Florida. But I can try to answer the first one. I'm not aware of any standard related to asthma, and that's because we are not a health organization. We are not going to provide a comment about asthma. There are many things that trigger it, and filtration was discussed earlier, so I think that that's something we have to consider. But I know from friends of mine who are asthmatic that usually it's local filtration that helps them out the most in those situations. Jennifer, do you want to try to address schools in Florida?
Jennifer?
Well, I'm not going to talk about asthma and pathogens because that's not my specific area of expertise. But so a lot of things go through my mind. I'm not denying what's being said. It goes back to operations. It goes back to, again, when they built the building, they had to build the building to code. So it did meet a ventilation standard, whatever genre that is. But unfortunately, and Meghan knows this because she sees the same problem in Georgia as well. And one of the reasons why we discussed that point about controlling to dew point, it's very important. Many school boards and school districts allow this. I fortunately don't have to deal with them, but a lot of them shut their schools down over the summer. So there is no ventilation, no exhaust, and they just sit, and this is in order to control energy. So they just sit there for 2 to 3 months with potential humidity levels. I'm going to say, over, basically you've got 80% relative humidity in some of these spaces because it's like, 80 degrees, and they've just shut them down. They've let, maintenance go. The other thing is, and I don't want to, pick on, Joe Public here and say, hey, we have to pay more taxes. But a lot of the, let's just say more advanced school boards, they are trying to put in, penny cent taxes and here and there. And I know a lot of my friends have been doing the designs, have been selling the equipment, and been doing the installs to improve the air conditioning systems in these schools, because I do think these school boards recognize that they do need to have a better program to improve their indoor air quality. Again, it's not my area specific, but I do know from stories I've been told is that they do shut them down over the summer, and that does create a lot of these problems. The other problem is during the pandemic, again, where you had milder climates, the instruction was, oh, you can open windows and open it. You just really can't do that in Florida. I mean, you can open the windows, but it becomes more uncomfortable for the occupants, and then again leads to more humidity issues. I did have my challenges even at my university, mainly because we had a building that was not air conditioned, or parts of it were. And again, you might condition your cafeteria, and that has a great system, plenty of outside air. But then what happens in the classrooms, and what happens when the maintenance guy shuts the outside air damper on that rooftop unit, and now you don't have any fresh ventilation? And do you really know, if that's happening or occurring? I emphasize, I'm a parent myself, and I do have concerns, about what to do about the children. I just think I would encourage folks to be involved with your school boards and understand what they're doing for their systems and their operation.
I see a lot of discussion about dew point or relative humidity, whichever way you want to look at it. I prefer dew point, but I think, Brendon, you pointed out some of the reason why people are, concerned about going to just dew point. But I see a lot of discussion about that and health, especially with respect to the pandemic. Is that something that you're focusing on a little bit more now, because there's an optimum range for relative humidity, and especially when we're dealing with viruses and so forth?
So it's interesting that you bring that up, because one of the other hats I wear is I assist Standard 170 with their research projects. And one project that we've been kicking around for 4 years has to do with temperature and humidity set points to control infection risk. And what the idea is that we're looking at where certain diseases are prevalent in the world, and they're tied to specific climates. So for example, you tend to have measles in cold, dry climates. You have a flu season. You have a COVID season is what we're starting to see. So obviously pathogens respond to humidity in different ways. Some of them actually like high humidity. Some of them like low humidity. The middle range of humidity, we have a member in ASHRAE, Dr. Stephanie Taylor, who talks about 40 to 60%. This is her mantra, that if you keep our relative humidity in that range, the immune system is going to be at its peak condition, and therefore you're at the lowest risk of infection. And she's been trying to work on studies to prove that. At this point, we don't have that evidence in here, and we do have a lot of evidence of the problems caused by mechanical humidification in healthcare facilities, which is why you've seen those standards get loosened, so that people who don't have to run a humidifier aren't running a humidifier. So it is a very big challenge, and it's a very salient topic in our community. We're looking for that research. We are actively funding and seeking funding for that research, both within our organization, and we're happy to support others who are seeking it from other organizations. Just let us know. We want to have that answer. But yes, it's an important topic, but I don't think you're going to see changes to the standards immediately around it, because it's still an emerging topic.
And we've had Dr. Taylor on the show in the past, so if people want to listen to her thoughts on the topic, you can go back to the archives. All right, before we go, I want to get a final thought out for everybody. I'm sorry we didn't get into the IAQ procedure, so if anybody wants to touch on that on the way out, I'd be happy to hear that. But let's start with Jennifer. Final thoughts, anything we missed, anything you'd like to add?
When I was working on the guideline, I got to work with many industrial hygienists and scientists. And again, I guess, sometimes I had my engineering hat on so long that I didn't think about building as a system. And I know you've talked about that plenty of times on your previous shows. And my simple way is the 4 Ps, people, pathogens or pollutants, pathways, and pressurization. And really, when you have a problem inside your building, it's usually one of those 4 or some combination thereof. So never just think it's, oh, the engineer didn't design it right, or it didn't get built right. You usually have a bigger problem happening, and you have to almost put that detective hat on and really look for it. And I know that's what a lot of your audience probably is those detectives, and they keep us all out of trouble and keep our occupants safe.
Thank you for that. I'm sure Mike McGinnis will appreciate it. Mike, I've been advocating for the 4 Ps for many years. Meghan, let's go to you next and get your final thoughts, and we'll finish up with Brendon.
Yeah, I want to move away from the framing of energy efficiency versus indoor air quality. And instead, we need to achieve both of those things and more, all at the same time. There are always trade-offs. So keeping both things in mind, and turning the discussion to how are we going to fix our existing buildings? What can we do now? They need help. We need to fix them and not create more problems and not increase energy by a gazillion. So
that's a great point. We appreciate that. And let's go back to Brendon. You get your last thought, Dr. Burley.
Joe, I would be happy to get you in touch with the people who can really talk about the IAQ procedure. We have several members of the committee that have worked on developing that. It's much simpler for designers. There's a lot more clarity as to what contaminants interact with each other, what the limits are in the standard. And we hope that it's a lot easier for people to use than the previous procedure for those reasons. As for final thoughts, I just want to emphasize again, I understand that consensus is hard. We all understand that consensus is hard, but it is the right way to approach issues of standardization and making sure that the industry can move forward in an efficient and meaningful way. ASHRAE has been at the forefront of pushing the boundaries on energy efficiency, on indoor air quality, on ventilation from the very beginning, and particularly in the last 30 years. And we hope to continue to lead in these efforts. And I think that this new pathogen mitigation standard is going to be a helpful stepping stone along that road. It is the beginning, not the end. Once that document is published, it will move to our committees, and where there is strong evidentiary basis where we can make effective changes, those will be incorporated into our standards. Where there is still room to grow, we will promote research and we will guide research internally to find that information so that we make sure that we can move it forward. At the end of the day, I know it's frustrating for people who want to see action now, but this is the way that we should be doing things. We want to make sure that we move forward together and we don't leave anyone behind.
Well said. All right. I want to thank our guests for this week, Dr. Brendon Burley, Jennifer Isenbeck, and Meghan McNulty. My co-host, the Z-Man, Cliff Zlotnick. John, you got to have faith at the controls, our fantastic sponsors, and our loyal audience. We appreciate you, every one of you. Next week, we've got Andre Desjardins and Michael Lubliner from the Oak Ridge National Laboratory. We're going to be talking about their new building science advisor tools. Now, I'm looking forward to a great show with them. We've been trying to get that together for quite a few years now, and happy to report we've got it next week. And thanks to Pete and Sigley for helping with that. So this is Radio Joe Hughes saying thanks again to our guests and everyone that's tuned in. We'll be back next Friday at noon with the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.